Hello everyone, today we are going over the Blind 75 in C++, and today we are working on non-overlapping intervals. Now before we get started, make sure that we have our 4 questions already labeled out. Feel free to pause the video to write them down if you're following along. We need to ask ourselves what the input is going to be, what data structure / algorithm / technique to use, what to do with the data, and what our output is going to be. So to be able to give a breakdown on the following question, given an array of intervals, where intervals I equals start of I, end of I, return the minimum number of intervals you need to remove to make the rest of the intervals non-overlapping. So if we were to go over the examples that we have, we'll be able to get an idea. However, one thing that we should take into consideration is that we already know exactly what our input is going to be. We are given an array of intervals. You can even look at the input up here in the parameter. And then it looks like we need to return the minimum number of intervals you need to remove to make the rest of the intervals non-overlapping. We will expand upon this. And just to give a visual example over exactly what they mean, let's go over the examples. So if we are given an array of intervals, for instance, our output is expected to be 1 in this case, and the reason being, as they state, is 1 and 3 can be removed and the rest of the intervals are non-overlapping. So if we have all of the numbers inside of our intervals array, so we have 1, 2, 3, and 4 for the most part, and what it looks like if we were to remove this overlapping interval that we have, 1 and 3, because if we were to scan the rest of the numbers, we see 1 and 2 is inside of 1 and 3, and 2 and 3 is also inside of 1 and 3. So highlight the numbers to visualize the relationship between all the elements and for our input and output. And if we were to go forward on example 2, we have, so in this case it makes sense over exactly why the output would be 2 in this case for the minimum number of intervals we have to ultimately get an array that would have intervals where all the numbers are non-overlapping. And we need to return the number of intervals one needs to remove to make the rest of the intervals non-overlapping. And for example 3, it looks like between 1 and 2, 2 and 3, 0, because even though it may appear at first, if we were to expand more, based on this example, and our output is 0, the reason being is, hey, we have 1, 2, and 3, 1 and 2, and 2 and 3, even though they're connected by 2, they're not overlapping technically. It's really just in the case like this one, for example, 1 through 3, and then we have 1 and 2 where we have a number inside of our interval. Overlapping is when we have a number inside another number inside our interval. And so the technique that we will be using, that I'll be introducing to your folks for our solution to be able to solve, is going to be a greedy algorithm with sorting. And what I mean by that is that a greedy algorithm is more of a technique, really, that explores all the possible relationships within a given series of elements that we are given. Meaning that if we, for instance, are given an array, we need to discern exactly the relationship from all of the elements and all the possibilities that are possible. And this is typically widely used if one's just trying to figure out exactly, hey, if we have this set of these set of elements, what's the relationship between them? And we're going to be implementing a sorting technique first to organize all the intervals all together, because we know that we know our start and end numbers are going to be different in relationship, and we're going to expand upon that relationship. So Moving into the steps over how we're going to solve this is that the first step is that we're going to sort the intervals by their end times. Then we are going to initialize a variable to keep track of the end time of the last interval. Then we are going to initialize a counter for the number of intervals to remove. And we're going to have a for each loop that we will have for each interval in the sorted list of intervals. We're going to do two cases. If the start time of the interval is greater than or equal to the end time of the last interval, we're going to update the end time of the last interval. And then for B, if the start time of the interval is less than the end time of the last interval, we're going to increment the counter. And then finally, we're going to return our counter. So to be able to break down the steps over how we're going to write this all from English to regular code is that the first step, in order to how to sort all of our vectors of a, so we would have an array inside of an array technically for the entire thing, we are going to call upon a sort function that we will create and then use. So we're going to have intervals from begin to intervals at the end. And then we are going to have a series of vectors that will indicate the relationship between the start and the end. So we will have this one here for and A, this one for B, and then inside what we will be doing okay. There we go. Is that we're going to have return A of 1 less than B of 1. So that way we can expand upon the relationship of the beginning and the end. It will be like, for instance, we already know if we were to have 1, 4, 3, and 2, such as in this type of array, we know that 1 and 4 are going to be different as the min and the max. So it's going to be 1, 4. That's how we expand upon our relationship accordingly. And then the next step that we will be doing is then step 2. We're going to initialize the counter, so and a variable to keep track of the end time of the last interval. So for step 2, we are initializing a variable to keep track of the end time of the last interval, and what we'll be doing is that we are going to be doing an int min to start with. And it may be confusing because you think of end as max, but the reason why that we're going to be starting off as int min is, say for example, since we're starting off from absolutely nothing to begin with, we need at least one variable that's going to be greater than what would be provided. And so the reason why that we have int min, it's kind of like saying, for example, if we were to start our given interval with 1, just to give an example, if we were to start our interval at 1, that could be just the entire base that we would have. And if we were to figure out exactly what our maximum will be, we don't know what it will be, but we are starting this off as the maximum value, such as we're setting a baseline, and then eventually in our for loop, what we are going to be doing is that we're going to be updating our last end time to become the maximum value. and it will be further explained in our solution. And then step 3, this is where we initialize our counter. Our counter, it will be int count to remove at 0. And then we're going to head over to step 4, where we're going to create a for each loop accordingly. So for auto and interval for intervals. This is for A, if the current interval at the current index is greater than or equal to the last n time, if we have a given value, then what we'll be doing is that we are going to update last n time to be the next interval value that would be up. So that way, therefore, last n time will be the maximum. Declare last n time to be our maximum. And since we're going to hold this accordingly until we reach the end of the entire intervals array that we have, that means for our counter, if this will be for B in this case, where if the start time of the interval is less than the end time of the last interval, and we're going to increment the counter, it's kind of like saying, oh, hey, for instance, if we have an interval starting at 1 and we have another, integer we come across, that's the same. It's technically overlapping. So it would be like 1, 1 in that case. And therefore, we will increase our counter and finally, we're going to have our output, which will be step 5, and that's going to be return count to move. We need to increment this accordingly while we are going through our entire for loop, as indicated right over here. Now let me just double check to make sure it's all correct. Count to remove right here, yes. Gonna run this to make sure it's all correct. Alright, it passes all the test cases. Let me just clean this up for you folks, just to be sure that we are keeping everything correct and clear as possible. And I'm going to have this in the comment section as well. Alright, make sure it's right. Pass all the test cases. Okay, now just to give a rundown on everything for our solution, is that the time complexity for our solution is going to be of O n log n, where n is the number of intervals, and this is due to sorting in step by step at the beginning, while the space complexity for our following solution is going to be O of 1, as we only use a constant amount of space to keep track of the last n time and the number of intervals to come to remove. So yes, this was non-overlapping intervals. Thanks again for taking time to watch this. If you found this helpful, feel free to like and subscribe. And if you have any other questions, feel free to put them in the comment section. And as always, take care. Cheers. Bye-bye.